Newton-Raphson method. The Newton-Raphson method is another iterative method to approximate the root of a nonlinear equation by repeatedly find a tangent line of the equation. So we can see this tangent line. So it find a tangent line that passes through 2 points x0 and x1. Hence, in general, we get the solution of nonlinear equation via Newton-Raphson method, also known as Newton method, which is given by this formula. So if you would like to know how the derivation was done, you can try to find the Newton solution derivation. Okay, so we will proceed with exercise. Before that, in order for us to make sure that it's easy for us to use the calculator, we need to represent the equation in terms of variable. So we can represent xi not as usual, xi a label, so we can represent fxi b, f prime xi as c. So from this formulation, we would like to find the new estimation for the x. So in order to do that, we need to use this Newton method table. So we will have iteration here, okay, and we have our x value here, fx and f prime here. So we will indicate that this is actually a, our a here, this is our b, and this is our c. Okay, let's try example. Make sure you prepare your calculator. Example 2.7. Given the graph of fx equal to x power of 2 minus 3 as shown in this figure 2.8. Approximate 3 by using Newton method. So this is actually your stopping criteria until you find the tolerance value less than 0.005. The first step that you need to do is to find the initial value. So if you can see in the graph, there are two lines that intersect at x. So we have the negative side between minus 2 and minus 1 here. And here we have between minus 1 and minus 2 here. So we can see that it is approximately, we can also see actually what is the value. It's somewhere between 1.7 something here. So in order to make it easy, so we will choose one initial value for x. So the first step, so we need to approximate, so 3. So if we rearrange back this formula that given here, okay, you can see here, rearrange back, so you can approximate that set 3 is to find the positive root of fx, x power of 2 minus 3 equal to 0. So in this case, because I would like to have the positive root here, so I can choose, I have to guess the initial, so I would like it easier for me to choose these 2 value rather than 1. So I would like to choose 2 because this point is nearer to 2. So I would like to choose 2. Okay. In Newton-Raphson method, you need to make initial guess. That is the first step. So the second step is for us to tabulate this Newton method table. So we will use this formula after that in order for us to find the new x I plus 1, so the next x. So this is the older x and this will be the new x. So we have choose x not equal to 2, so we will put in the table x is actually 2. So this is actually our a, and then we need to find fx. So in order to find fx, you just need to use the formula given here, or this one you can see the x power of 2 minus 3. So you just put 2 in this formula. So if here is 2, if you can see, if we put 2 here, so we have something like this. So 2 power of 2 is 4, 4 minus 3 is 1. So we can find the new value for fx. So in this case, our fx is 1. Now we would like to find our fx prime. So what you need to do is to make sure that you have to derive, you have to find the f prime of this equation. So you can either do it manually, or you can use calculator to differentiate your fx. So what you can do is try to use your calculator, insert it this formula, so you will get something like this, and then press equal, and then it will show you 4. Okay, so you can find your f prime value is 4. After that, we will use the Newton-Raphson method to find the new xi plus 1. So in order to do that, we will use the formula, the Newton-Raphson formula here. Key in your calculator, so as shown here. So you will have something like this. Okay, try to key in now. Okay, then from this formula, you need to key in the value for A, for B, and for C. Use the calculate and then enter the value. For example, you have already keyed in the formula, and then press calculate, enter this value. For A is 2, so 2 equal, and then B here is 1, enter equal, and then 4, and then you will get your value here, okay, 1.75. Down you will get 1.75. So I hope all of you can find this and get the same value. Make sure you have fixed your calculator into 4 decimal places and also in a radian mode. That is the most important part. Then we will continue to find the fx. So insert x 1.75 in this equation, so you will get the new fx and also the new value of 175 in the f prime. Here you use calculate, just replay back the previous formula and then get the whole complete value for this table. So remember, use calculate and replay. Do not press on, always press AC to make sure that you have the previous formula in your calculator. So when you gonna stop? So you will stop until you find modulus fx1, or sorry, I must be less than 0.005 as mentioned in the question. If the question asks you for 0.002, and then based on the question, so in this case the question asks you for 0.005, so you have to do the whole process until you see this fx, because it's requesting for fx. So look at this fx. So is it less than 0.05? Yes, for this iteration number 2. This one is not yet complete, and then we will proceed. And then when you see at the iteration number 2 that you can see that it is less than 0.005, so yes, meaning that you can stop. So since it is less, then the positive root of x power of 2 minus 3 equal to 0 is approximately 1.7321. So this is the whole solution for the Newton-Raphson method. Do not forget to summarize your answer. So if you look at this graph, 1.73 is actually near to these two. So it is visually you can see that, okay, your answer is correct. Okay. Next, we will go to the second example for Newton-Raphson. So in this example, the question asks you to find the most positive root of the nonlinear equation of the following graph using Newton's method. So if you can see here, there are several intersections at x-axis. So we can see here is 1, we have this at 0, 1, 2. So this is the third intersection. So we have 1, 2, 3. So which one to choose? If you refer back to the question, it asks you for the most positive root. So this is actually our negative root, so we do not want it. So we would like to find positive. So we have 2 here. 1 is here and 1 is here. And it asks you for the most positive root. So in this case, should be this one. Okay, so then we can proceed. Okay, here is the given equation for this function. Okay, so we have already this function given in the question, so we proceed. So if you can see here, this is the equation that given. See, because we need to fill in this table, so we need to have x, fx, and f prime. So to make it easy, so we have already our fx. So how about we find the prime first? So in this case, I use prime, and then I get the equation. If I prime this, or derivative of, I differentiate this equation, so I will have this one. Okay, after that, you can also use your calculator. Next, we need to find the initial guess. So in this case, I would like to choose x naught equal to 3. Because of what? Because of the most positive root in the interval, I find that it is 3 and 4. So I can choose 3 or 4. So in this case, I would like to choose 3. Okay, after we already have our x naught here, 3 here, so we need to have our fx. So what we're going to do, so put x3 inside here, so 2, this is 3 power of 3 minus f 3 power of 2 minus 7x, this is x is usually 3, and then plus 6, so you will have your new value for fx. So you will find minus 6. Okay, you can just use your calculator. Use calculate button, and then use this value, put and use this as 6x power of 2 minus 10x minus 7. So you have 17. I hope you can get this easily. Please try now. Do you have the same answer as me? Great. Then we proceed. We would like to find the new xi plus 1 here. So we will use the Newton method formula here. So use the formula, and then you will have your new 3.3529. So let's try. So I have the same formula here. So I will enter, calculate. So my x is 3. My b is minus 6. Don't forget the minus sign. Okay, and then our my c is 17. Okay, and then okay, so I will get 3.3529. Okay, so this is my result for my equation here. Okay, so you can proceed to find, enter back here. Okay, this new value of x here, so you can find fx and f prime. Use the calculate and use the same formula. So you can make sure you have the same answer as me. Okay, so when to stop? In this case, we will use the same stopping criteria. So it should be less than 0.005. So we look at fx. So if you can see, this is 0.004, so it is less than 0.005. Okay, see, you have minus here, no problem. We will ignore the sign because this is modulus. It only counts the value. So if you modulus here, so you will cancel this one, so you will have 0.004. So you can stop. Please stop. If not, you will not find the stopping point afterward. It will be the same answer. Okay, so stop here. So what you can conclude here, that our fx here, so approximately our roots is 3.2871. So this is the answer for this question. Okay, I hope that you can understand this example, and please try again to see whether you get the same answer as we do in this exercise.